welcome back. In the last few lectures, we started our journey with crash course on propositional logic. Then followed by that, we used semantic tableaux method to solve some of the important puzzles like knights and knaves and lady or tiger. Then we saw some of the limitations of classical logic, particularly this that classical logic fails to differentiate things such as something which is actually the case, something which is necessarily the case, and something which is possibly the case. There is no difference between box P, diamond P and P. And the second thing is that classical logic fails to deal with future contingent sentences. So these two things led us to the development of modal logic. And the third important thing which we have seen in the last class is there is a thorough dissatisfaction with the material implication. The material implication is simply defined as P implies Q is defined as not P or Q, or it is not the case that P is true and Q is false. So there is thorough dissatisfaction with the material implication, especially when you use it in the day-to-day discourse. In particularly, it leads to counterintuitive kind of results. So in this lecture, we will be considering some of the historical origins of modal logic, and you need to note that this is in no way exhaustive kind of survey of modal logics, but I would like to highlight on some of the important things which is considered to be important for us. So I will be talking about historical overview, and in the next lecture I will be talking about something about the strict implication, because the strict implication is the one which led to the development of various modal logical system, and that is what we are going to take up in the next week. So here is an interesting quotation by this author M. D. Rijke and I. Venema. Their book is considered to be a very popular book. Anyone who takes this modal logic will definitely view this book. It's a very interesting book. So he is of the view that in the preface he mentions this thing: ask three modal logicians. If you come across any three modal logicians, you ask them what modal logic is all about, and you are likely to get at least three different answers. All are possibly true. So it is what is written in the preface of this book, Modal Logic by Blackburn, Rijke and Venema. It is still considered to be a classic book a classic book on modal logic, apart from Hughes and Creswell on new introduction to modal logic. So there are two main notions of dealing with modal logic. One is the syntactical view, in which the logic we will be giving importance to the logic of modal sentences like possibility of P, necessity of P, etc., and we will be dealing with the nature and behavior of these modal operators. So till 1960s, modal logic was extensively studied in this tradition, and from 1960 onwards, ever since Kripke has come up with possible world semantics, it is considered to be a revolution. You can consider it as a revolution in modal logic. We view validity, etc., in a totally different way. So there what was important is the logic of relational structure. There was a lot of emphasis on the relational structures. So these relational structures we are going to talk about it in next week. These are also called Kripke frames. But these two traditions, these two notions obviously do not coincide. There are a lot of debates as to which approach is considered to be the most adequate kind of approach. These are the two notions of modal logic. One is the syntactic tradition and then the semantic tradition. So I will be in the coming next few minutes I will be talking about modal logic while dividing it into four important phases. One, we go back to Greek period, where we will be talking about Aristotelian modal syllogisms, and then we will move on to, of course, although medieval period is considered to be the most important thing, then we will jump to syntactical era from 1918 to 1959, and ever since Kripke has come up with the possible world semantics, and it is considered to be a classical era. It is from 1959 to 1972, and the modern era is the one which you witness it now. A lot of developments, applications of modal logic, particularly in linguistics, computer science, artificial intelligence, etc. So you will often find courses like modal logic for artificial intelligence, modal logic for computer science, modal logic for linguistics, etc. So all these things are the ones which you will see, mostly the applications of modal logic. So let us go back to the ancient past, where in the Greek period, particularly in Aristotle's work, Aristotle did talk about modal syllogisms. So it dates back to Aristotle's de-interpretation, in that there was a problem of future contingent sentences. So the future contingent sentences, the problem with the future contingent sentences is that what truth value it takes. So it is this a sort of logical paradox which was discussed by Diodorus Cronus and Megarian school of philosophy as well. So the problem here is that suppose if you make the future contingent sentence true now, then whatever happens was necessarily going to happen. That means whatever is true now is going to be necessarily true even tomorrow and always. So then it cannot be, it is not possible that a particular kind of sentence will become false. So what does not happen, suppose if you make the sentence false now, it is absolutely, it is the case that it does not happen. Whatever does not happen was necessarily not going to happen anyway. So things which are considered to be false are necessarily is not going to happen. So Aristotle was worried about how to preserve law of excluded middle, that is P or not P, and at the same time how do we incorporate these future contingent sentences. For Aristotle, statements about future contingent sentences like I will be in my native place and so date, etc., they are neither true nor false. He wants to preserve the law of excluded middle. So this is the one which we get it, and it is translated by Ross in 1928. It goes like this. So Aristotle in de-interpretation is of the view that if a thing is white now, it was true before to say, just before some time it was true before to say that it would be white, so that of anything that has taken place, it was always true to say that it is or it will be. But if it was always true to say that a thing is or will be, it is not possible that it should not be or not come out to be. And when a thing cannot come to be, it is impossible that it should not come to be. And when it is impossible that it should not come to be, it must come to be. So that means all then that is about to be must of necessity take place. So this is a kind of deterministic kind of position. Whatever happens out of necessity, whatever doesn't happen anyway. So it results from this that nothing is considered to be uncertain, or nothing is considered to be uncertain in the sense that whatever happens out of necessity, whatever doesn't happen also happen out of necessity. It is anyhow is considered to be impossible. If you make the future contingent sentence true now, it is necessarily true, and if you make the future contingent sentence false, it is going to be absolutely false and it is never going to happen. For example, if you say that you booked your ticket and you will be in your native place, suppose if you make the sentence true, that means you must travel, you must go to your native place on so and so date. There is no way in which you can postpone your journey or something like that will happen. It might happen that you booked your ticket, of course, but you may cancel your journey, or the train is late, or train is cancelled, etc. But you may not be able to reach your place, or you may be able to reach the place next day. So it is not necessarily going to happen. Suppose if you make the sentence false now, suppose if you say that I will be in my native place and so date on December 21st 2016, if you say that thing, then suppose if you make the sentence false, anyhow it is going to turn out to be the case that it is necessarily false. I mean, it cannot happen that you will be traveling to your place on December 21st. It prevents you to go to your native place. So it results from this that nothing is uncertain or fortuitous. For if it were fortuitous, it would not be necessary. This is what is translated by Timothy Ross in 1928. So Aristotle also spoke about square of opposition. It is going to be like this. He spoke about 4 kinds of prepositions, categorical prepositions. So they are like this. For there are 4 kinds of prepositions which he has considered, and then these categorical prepositions combine together in some ways, and then they will form another categorical preposition which is considered to be the conclusion of the syllogism. A syllogism consists of categorical prepositions. 2 will serve as premises, another one which is considered to be the conclusion. So Aristotle's square of opposition is obvious to us. So it is like this. Suppose so it is like this. So on the one hand you have an A preposition which stands for every S is P. First of all, any sentence will have this particular kind of structure. It has a subject and it has a predicate, and then every S is P is a preposition, and then you have something called as some S is P. So this is I preposition, and then you have E preposition which states as that no S is P and some S is not P. So now you need to note that Aristotle spoke about these connections between these 2 things, the diagonals as well as the parts of your square. So these 2 are opposing to each other. That means these 2 are contradictory to each other. So these diagonals are contradictory, whereas so these 2 are considered to be contraries, and the below one is considered to be subcontraries, and there is something called as alterns, subalterns, etc. So so this is the famous square of opposition. That is what you will learn it in any introductory course on logic. So now how to look into this one? For example, in this case there are various issues concerning whether from every S is P some S is P follows or not. So for example, if we say that all unicorns are intelligent, does it imply that there exists some unicorn and that unicorn is considered to be intelligent? So Aristotle is of the view that there is some kind of existential import in the conclusion. Suppose if you infer some S is P from every S is P, existence is imported from the premises to the conclusion. So this is also called as existential fallacy. There are various issues related to this one. So now these diagonals are considered to be contradictory. Suppose if you take both of them together, it leads to a contradiction. Suppose if you take this preposition as A and this as E, and the truth value of that one combined together is going to be false. And in the case of contraries are this one, every S is P and no S is P. So the problem with that one is that both cannot be true. In this case they are considered to be subcontraries, whatever is in the down of this particular kind of square. Here these 2 both cannot be false. If you take these 2 together, it cannot be false together. This is what is considered to be contrary, and contradictory means both have to be false together, or they are having opposite truth values. If this is having truth value T and the diagonal some S is not P will have opposite truth value. So this is what is the case of square of opposition, but Aristotle's square of opposition can be discussed in terms of modal syllogisms in this way. You can represent a preposition as necessarily P and E preposition as there is necessity of not P, and I preposition as possibility of P, and O preposition as it is possible that not P is the case. So it is simply this thing, A is this one, and then some S is P as this, and then O preposition is it is possible that not P. So I said in the beginning of this course that I will be using this notation. So this stands for it is possible that P. Suppose if you write like this, suppose if you say box box P, then it says that it is necessary that P is the case, that P is true. So now in this case it is E proposition is represented in this sense. It is necessary that not P is the case. That means not P is considered to be necessary. So now in that context the same square of opposition can be explained in terms of modal operators like this. A contrary proposition is the one, for example A and E, the truth values of A and E cannot be true together. That means it cannot be the case that necessity of P and necessity of not P is the case. So that is the first one, they cannot be true together. If you make necessity of P and necessity of not P, that means it is true. That needs to be ruled out. That's why we have put negation before that. And the subalterns are on the sides of it in particular. So from necessity of P, whether we can infer possibility of P, and necessity of not P leads to necessity possibility of not P. And subcontraries are there in the down kind of this square. Subcontraries cannot be false together. Suppose if you take both the things together, it cannot be false together. That's why you write it like possibility of P, or it is possible that not P. That means P is possible or P is not P is possible. Either one of the things should be the case. And contradictory propositions are represented in a slightly different way like this. They cannot have both truth values. So if P is true, then obviously not P, it's contradictory, will have the value F. So this is represented in this sense. Necessity of P is logically equivalent to necessity of it is not possible that P or necessity of not P is logically equivalent to it is not possible that P. So it is in that context Aristotle did talk about syllogisms etc. from A proposition, how it leads to I proposition etc. There are some various rules etc. He spoke about it in the Greek period onwards. Now coming back to the medieval period, it is worthwhile to mention Leibniz works. Leibniz lived from 1646 to 1716, because there were many logicians who were working in that period. Leibniz is definitely worth mentioning. I might be ignoring many other important contributions, but we need to emphasize on Leibniz because there is a technical notion that we will be using throughout this course. That technical notion is called possible worlds. This possible worlds, the introduction of possible worlds is due to, is the idea of Leibniz. So for Leibniz, a possible world is made up of individuals that are composable, I mean equally possible, that is individuals that can exist together, and possible worlds exist as possibilities in the mind of God, and one world among them is considered to be the best possible world, which we are calling it as actual kind of world, and this is considered to be the most perfect kind of world. That's why it is considered to be also considered to be the best possible world. So the idea here is that we have all are considered to be possible worlds only. Out of these possible worlds, one world is considered to be the best possible world, which is designed by God. So Leibniz wants to attribute all kinds of absolute qualities to God. For that he has to cook up with these best possible worlds etc. So the modal status of a proposition is like this: truth, true in an actual world; falsity means false in the actual world, that is P, not P etc. And possibility means in Leibnizian terms it is true in at least one possible world. Suppose if you say that it is possible that it is humid outside, there should be some at least one particular kind of world, a situation where your sentence is false there. Suppose if I say that it is possible that it is humid outside, it is also true that it is possible that it is not the case that it is humid there outside. So impossibility means it is true, something which is considered to be true in all possible worlds, or sorry, impossibility means no possible world. So in the context of conditional logic, particularly impossible worlds are the ones which we take into consideration in somewhat detail. All conditionals are considered to be vacuously true if the antecedent is considered to be impossible there. And necessity means it is true in all possible worlds. All the mathematical truths, etc., they are all true in all possible worlds which are accessible to the actual world. So all these things which I will be talking about it when I discuss about the semantics of modal logic little bit later. So contingency means it's true in some possible worlds and it is false in some others. In the syntactic era, the one particular kind of problem they were facing is this thing, the paradox of material implication. One of the ways to talk about this paradox of material implication is this. So from truth is implied by any kind of strange proposition, and if you start with a false proposition, it leads to anything. Falsity leads to anything. So it leads to some kind of counterintuitive results. If you substitute phi and psi with some ordinary propositions that you commonly observe in our day-to-day life, you will come across some kind of intuitive, counterintuitive results. In the syntactic era, we have axiomatic systems from S1 to S5 was developed by C.I. Lewis, proving the distinctness of these theorems, etc. But one of the important problems of this syntactic era is that till 1960s they continued in this tradition. It clearly lacks natural semantics. And three lines of work to the next stage are like this: Carnap's state description, close to possible world semantics. Possible world semantics got some kind of inspiration from Carnap's state description, and Prior's tense logic were also developed along the same time, but unfortunately there was not less influence of temporal logic on the modal logic for a long time. So Prior's tense logic with semantic ideas and insights, and then Johnson and Tarski, say presentation theorem, etc., are considered to be the other possibilities. So if we can classify the syntactic era, the main results are like this. There was thorough dissatisfaction with the material implication, which led to the development of strict implication, and it mainly the results of distinctness of Lewis systems S1 to S5, and Gödel's extended this thing, defined this Lewis systems using the modern notation, proves that intuitionistic propositional logic IPL, which can be translated into the modal logical system, which we are going to talk about a little bit later, that is S4. And McKinsey and Tarski defined some kind of algebraic semantics of algebras with the operators for Lewis systems, and show the decidability of S2 and S4. The idea here is that Lewis has come up with there was thorough dissatisfaction with the material implication that led to the development of strict implication, and in the process of understanding the strict implication, Lewis has come up with 5 different modal logical systems from S1 to S5. The first 2 systems he calls it as non-normal modal logical systems, and S4, S5 are the ones which are widely studied, and these are considered to be normal modal logical systems. So in the classic era, other things which you will find it is these things. So far we talked about pre-era and syntactic era, and then classic era. So from 1960 onwards, some revolution in the logic, so that is Kripke semantics. So where accessibility relation, depending upon the constraints on accessibility relation, we have different modal logical systems. The emphasis was given to much emphasis was given to the relational structure. These are considered to be analytical tools that is not really to be described. These are all abstract things. Many applications in modeling of agents, etc., were the ones which are there in the classic era. Is what you will find it in the classical era. This is a period from 1959 to 1972. And the different modal logics, semantically defined systems, etc., modalities viewed as alethic modalities, temporal, doxastic, deontic, etc. And then they discussed about the problem of completeness. They have come up with the modal theory of modal logics, and the method that they used was relational structures. And one of the strengths of the classical era is that there was particularly clear insight of several modal systems, and there was clear relations to propositional and first order logic, but one of the weaknesses is that there is a lot of emphasis on the relational structures. So in the next class we will be dealing with exclusively about something about strict implication, which led to the development of modal logics. Thank you.